It's like I don't care about nothing, man. Yeah. Oh,
Alright, so this video is going to be going over more proofs. So on page 5 we're going to have more actual formal proofs, whereas page 6 is a little bit more informal, so just trying to prove something based on the stuff that we did through pages 1 through 3. So yes, I hope you enjoy. Okay, so now we're doing more practice with proofs, and we're starting on page 5 looking at number 5. Now in this one it says given C is the midpoint of AD, prove that X equals 6. So whenever you have a picture, one of the things I suggest always doing is mark up what you know. Now, they say C is the midpoint. If C is the midpoint of AD, then both sides should be equal. So if you remember from earlier, I was talking about how when we say something's equal in a picture, we do the little dashes. So since they both have one dash, I am saying that they are equal. Now, another thing that I hope you remember, and it's really important that you do, is when you do a proof, you always start in the statements with what's given to you. They already wrote that. The first reason is always, always, always given. So that is one that you should never miss. You should always be getting partial credit on these because that's something that you should know right off the bat. Now, they talked about midpoint. Whenever you see midpoint, one of your answers is always going to be, for your reason, is always going to be definition of midpoint. So let's look at the next one. They say AC is congruent to CD. So because they said it was a midpoint, we knew that they were equal. And we know that because of the definition of midpoint. The next one is filled out for us, but I'm going to look at it. It says AC is equal to CD. So congruent segments have equal length is what they said. Now, right under it, they set up an equation. So they are saying 4x is equal to 2x plus 12. That's the two equations that we have. We set them equal to each other. So when we had two things that are equal, this is one of the ones where I told you that it's super important. You should highlight it. This would have been the stuff on page 2 that I told you to highlight. Now, when there's two things that are supposed to be equal, we call that symmetric. Whoops, I'm spelling it wrong. Not always the smartest guy when it comes to spelling.
What an idiot.
Symmetric property of equality. And I went with the one that says equality instead of property of congruence because it has an equal sign, not a congruent sign. So the next one, they told us that the reason is going to be subtraction property of equality. So they're saying we had to do some kind of subtraction. Now I'm going to go ahead and write this equation off to the side so we can go ahead and solve it through these steps and see why we would have had to do that. So we had 4x equals 2x plus 12. Now, if I want to get x by itself, I do have to actually do some subtraction. I'm going to subtract the 2x from both sides. This makes it so all the x's are on one side of the equal sign. So that's why we have the subtraction property of equality. When I do this, what they want us to write is whatever we have left over. So now we have 2x plus 12. So in my statement, I would be putting 2x plus 12. 2x equals 12. I'm making all kinds of mistakes right now.
What an idiot.
But I'm only human after all. Now, the last thing is they got x equals 6. If I am going to get x equals 6, I had one last step to do. So right now it says 2x equals 12. In order to get x by itself, I then had to divide. So if I divide, it cancels out the 2's, and I have x equals 6. Just like it has in the last statement, which is what we're trying to prove. So the last step we did was division. So we had on page 3 one that goes with this. This would be our division property of equality. So that would be how we go about solving number 5. Okay, so now we are looking at number 6. Now this one, we were given that angle 1 is congruent to angle 3. So this angle and this angle are supposed to be congruent. They want us to prove that angle AFC is supposed to be congruent to angle DFB. So first off, I noticed that they put in all the statements for us. All we have to do is fill in a few of the reasons. That was very nice of them. So first things first in a proof. If you have not figured this out yet, you need to make sure you listen. You always start with what's given. So in the statement is what we're given. The reason is always given to start. If I don't have something given to me, I cannot answer the question. I cannot do a proof without something given. So first off, they have angle 1 plus angle 2 is equal to angle AFC. So angle 1 and 2 create angle AFC. They say, and they told us that that was because of angle addition. Next, we have angle 3 plus angle 2 is equal to DFB. So, same idea as the one above. This would be angle addition. So we were saying the same type of thing except with different angles this time. Next, they say angle 1 plus angle 2 is equal to DFB. So even though angle 1 and 2 aren't both into that angle, they're saying that if they would have the same numbers. So if that is the case, we could say substitution because it can go in either one and we're going to have the same numbers. Now last, which is what we're trying to prove, is that angle AFC is congruent to or equal to angle DFB. So you notice this is going to be one of the ones that I told you to highlight, star, make sure you know it's important. I'm having two different things saying they're supposed to be equal. When it's two of them, that is symmetric. And if I want to be extra with it, symmetric property of equality. Okay, so next we're looking at page 6, number 1. It's saying that line PQ is the perpendicular bisector of the line segment AB. Prove that point P is equidistant from the endpoints of AB. And we tell you where each of the points are. And I give you a hint to use distance formula. So first thing I want to make sure that you know is the perpendicular bisector. That's the important thing here. So perpendicular tells us that it's going to be 90 degrees. We're going to have a 90-degree angle. And bisector tells us it's going to be cut in half. So what I would suggest trying to do is before I put up everything for you, I would say try it yourself, pause it, and see if you get the same thing as me.
Do you think I'm crazy? I'm not crazy. I just believe in you. And I believe in you. Call an order now.
Okay, so I have filled everything in for you. In the picture, I went and drew lines connecting A to P and B to P, because we're trying to prove that P is equidistant from each of these endpoints. So the way we're going to do that is by using the distance formula and showing that it's the same distance from A to P and B to P. Now, another thing to remember when we had the perpendicular bisector, perpendicular means that we're going to have 90 degrees, and the bisector means that this got cut in half. So the ones with just one dash go together, the ones with two dashes go together. So now AP, I went ahead and fill in using the distance formula, the distance from A to P. Main thing to remember when you're doing this is that even though I have a negative here, when I square it, the negative goes away. So that is the main reason why we square things, because you cannot, inside a square root, because you cannot have a negative number underneath the square root. So when I went through this, I ended up with 10 for AP. Same thing when I did BP, I had these points in here, so my x values together, my y values together. So 7 minus 1, 6. So I have 6 squared plus negative 8 squared. When I square them, I get 36 plus 64, which is 100. And since once I square root that, I get 10. So they both equal 10. So in this case, we have proved that they are going to be equidistant from each of the endpoints. So now number 2. Find the measure of the line segment MN. So we're looking at this over here. Justify with the appropriate theorem. So when I'm doing this, I have a 90-degree angle. I also have these dashes that let me know they are congruent. When I have that, I know I'm dealing with a perpendicular bisector. And if I am dealing with a perpendicular bisector, I know that MN must be equal to NL, just like how it was up here. So that means MN is going to equal 2.6. So now the last one I am going to do is number 3. Find the measure of BC, justify the appropriate theorem. So BC goes the entire length. Noticing that both of these sides are 38. So just like these ones, if the sides are equal, and I have this right angle, I know I'm perpendicular, and it's going to end up being a bisector. So again, we're dealing with a perpendicular bisector. So from B to D, this would have to be 12. Since I want the full length from B to C, I would have to add them together. So 12 plus 12, which would make it 24. So make sure whenever you see problems like this, again, I would try to do it yourself before you see me do it and see if you get the same thing. So that's the end of another video. For practice, I would like you to do page 5, number 4, and page 6, number 4. But a few things with this one. You probably noticed that I had symmetric as one of the answers multiple times. So again, the reflexive, symmetric, and transitive were all ones that I think are going to be very important for you. So later on, like especially when we have the test, maybe those are ones that we want to focus on and really know. Another thing that you should know by now is in the proofs, first thing is always the givens. The last statement is always whatever you're trying to prove. So that's another thing. You should always get at least partial credit on any proof because of that knowledge there. And then by the end of this video, you should also be comfortable with a perpendicular bisector. So if you are good with all those things I just said, I would consider you successful. And this is also something that can help you figure out what to put on your bell ringer. Because if you know those things, you learn something. So yeah, have a good rest of the day.